Blocks A, B, and C are aligned along a straight line on a horizontal frictionless surface. The masses of the blocks are m, 2m, and 3m, respectively. Block A is initially moving to the right along the same line at a speed v, as shown in the figure above. Blocks B and C are initially at rest. Block A collides with and sticks to Block B. The two blocks then collide with and stick to Block C. What is the speed of Block C after the collisions? Since the collisions all happen on a frictionless horizontal surface and there are no external forces doing work on the system, it is isolated. This means that the amount of momentum is conserved throughout all of the collisions. We do not need to solve the problem step by step. We need only to compare the initial momentum, which is m times v, with the final momentum of the three blocks stuck together, which is 6m times final velocity. This means that the final velocity is 1/6 of the initial velocity. This is represented by option B.